So we've talked about vertical asymptotes. Now we're going to kind of shift gears towards finding horizontal asymptotes. For any rational function where we have this a over x minus h plus k, what this a actually represents is just some constant. Alright, so it's just some kind of number, like 4 or -8, whatever. H is likewise just some constant. So again, just a number here. And likewise, k is just a constant. So the only thing that's actually not a constant here is really just this x. Okay? So when we're talking about the horizontal asymptote, as a result, since this is just some number, and you have a higher degree on the bottom, well, if you think back to algebra, anytime you end up, there was always one of 3 scenarios for the horizontal asymptote, where your degree was smaller on the top, which is what we're seeing. If they were exactly the same, your degrees on top and bottom, or if your degree on the top was larger than the bottom. Well, we're in that scenario, the first one, where the degree on the bottom is larger than the one on the top. And as a result of that, we ended up with a horizontal asymptote of 0 anytime that we saw that. Now, because we have, again, that just takes care of this rational function part. But then we have this plus k, so plus some constant number. So we'd have to tack on some constant, whatever that is. And as a result, we then end up with y is equal to 0 plus k, which is the same thing as saying y is equal to k itself. Okay. Now back to the 3 different scenarios. Here's the one where they actually have the exact same degree. Notice they both have, again, a is a constant, b is a constant, c is a constant, d is a constant. Pretty much most of these things in here are just constants. The only thing that are not constants are the actual x values. And as a result of that, going back, we are in one of the 3 scenarios. Well, here they have the exact same degree. In this case, the degree on top is 1, the degree on the bottom is also 1. And when you end up with that scenario, when they are exactly the same like this, your horizontal asymptote, back to algebra, will actually just come out to be y is equal to these 2 coefficients, these leading coefficients being divided together. So our horizontal asymptote would actually come out to be a over c. And if you've had me in the past, we've actually talked about y, and we've done a lot of the graphs with y. So if you need to see that, there are actually videos for that as well. Now when we look at example 4, kind of now utilizing this horizontal asymptote, let's go ahead and sketch what this function looks like. So we have f of x is equal to 3 over x minus 4 plus 1. We're kind of more in this scenario. We can see that the bottom degree, which is 1, is larger than the top. We actually just have some number here. So we're in this first scenario. And as a result of that, our horizontal asymptote, so our HA, just comes out to be, well, this first part is 0 plus 1, so that's our horizontal asymptote. Y is equal to 1. For our vertical asymptote, you still follow the exact same procedure like we did in the past. You're just going to set this bottom not equal to 0. So we have x plus 4, or I'm sorry, x minus 4 rather, is not equal to 0. Simply just solving for this, x is not equal to 4. That's where we're seeing that again, VA. So let's actually go ahead then and graph that. I'm going to do that actually in red so we can kind of see them as our boundary points, or lines rather. So we have 1 as that horizontal asymptote, and then our VA is 4. If you've had me in the past for like Algebra 2, or you've kind of heard me reference that these are kind of like that electric fence that you can't really cross. Now, when we want to actually go ahead and start to graph the rest of this, well, we've done our horizontal asymptote, we've done our vertical asymptote. Now we have to kind of start plugging and chugging some values in. So we have an X and a Y, and we're going to go ahead and pretty much just plug in some values for X and see what Y spits out. Now, when we're trying to think of potential values that we can go ahead and do, we're actually going to choose values that are to the left of our vertical asymptotes and some that are to the right of our vertical asymptote. All right, 5, 6, and 7. So we'll go ahead and throw those in. And again, these are ones to the right. And then some numbers that are to the left of our vertical asymptote would include ones like 0, 1, and 2, or 1, 2, and 3. We'll go with 1, 2, and 3. So when we go ahead and plug 5 in, we end up with 3 divided by 5 minus 4, which is 1, plus 1, which just comes out to be 3 plus 1, which is just 4. When we try plugging 6 in, we would end up with 3 on top still, divided by 6 minus 4 is 2, plus 1. So 3 halves, which is pretty much just 1 and 1/2, plus 1 comes out to be 2.5. When we try throwing 7 in, we end up with 3 still on top, over 7 minus 4, which is 3, plus 1, which just comes out to be, really this is just 1 plus 1, which just comes out to eventually become 2. So now just plotting those ones, we have 5, 4, which is right here. We also end up with 6, 2 and 1/2. And then 7, 2. Now when we're looking at the ones in the blue, this 1, 2, and 3, we have 3 on top still, divided by 1 minus 4 is -3, plus 1. 3 divided by -3 comes out to be -1, plus 1 is just 0. When we try throwing 2 in, we end up with 3 still on top, over 2 minus 4 is -2, plus 1. So -3 halves plus 1 just comes out to be -1/2. When we try throwing 3 in, we have 3 still on top, over 3 minus 4, that's -1, plus 1. 3 divided by -1, well that's -3, plus 1 just comes out to be -2. So when we go ahead and graph these, I'm going to go ahead and do it also in black though. Oops. So that way it's kind of like a nice consistent graph. I just wanted to kind of shift these up for the numbers so it's a little easier to see. Now going ahead and graphing these, we have 1, 0. So that's right here. We also have 2, -1/2, right here. And then 3, -2. It's right there. Now if we go ahead and connect the dots, we should see an image that looks something like this. Now keep in mind with these asymptotes, it should kind of hover. And that's not too good of a hover. It should kind of hover those asymptotes. And not really cross them. And likewise with this one. So that is more or less a sketch of what our graph would actually look like. And now when we would like to talk about the domain and range of this, well, just using our graph, we can see that for our domain, again, that deals with all of the x values. We are starting out at negative infinity because the arrow just signifies that it keeps going and going to the left. So we're going out toward negative infinity. And then our x values are approaching this vertical asymptote 4. Not quite reaching 4 though. And because it can't quite be 4, we have that parenthesis around 4. And then it picks up on the right side of 4, up here. Again though, same issue before, it can't quite be 4, so we have that parenthesis. And then as you can see, it just goes out and out forever and ever because of that arrow. Can't quite reach infinity, so again a parenthesis. And again, this is connected by a union symbol. So that would be our domain in interval notation. You could also write it as all real numbers, except where x is not equal to 4. For our range, behaves pretty much just the same way. We're going down toward negative infinity for our y values. We're approaching this horizontal asymptote of 1. Can't quite reach past 1 though. So that's why we have a parenthesis around him. Union, on the other side, it picks up right after 1 and goes onward and upward towards positive infinity. So we have 1, positive infinity. Again, this would include all real numbers, except where x is not equal to 1. Just another way to write it. So again, that is example 4 from the 0.2 set of notes.